I want to go over how we came to the table for if P then Q, both because it's so very important to know that table and because getting used to the style of reasoning that we're using here as we think about truth values is helpful. So the first step is to start from a general principle. Suppose you know that either P or Q, where we mean this inclusively, but as you'll see, the reasoning is pretty straightforward. From P or Q, it follows that if not P, then Q. After all, if you know that at least one of these alternatives is true and you rule out the first one, you're left with the second. So for example, if either Paula or Quincy is at the meeting, you can conclude that if Paula isn't at the meeting, Quincy is. So now we can just state what the general pattern is. From an or statement, we conclude if the first part of the or statement is false, then the second part is true. So that's the first thing to understand. When an or statement is true, you can conclude if the first part is false, the second part is true. Now the next step, take a slightly more specialized version of the or statement, not P or Q. By the same reasoning, it follows that if P, then Q. Why? We just said, from an or statement, you can conclude if the first part is false, the second part is true. In this case, for the first part to be false means for P to be true. And so our interim conclusion is this. Whenever not P or Q is true, so is if P, then Q. Now for the next step, we're going to think about if-thens for a moment and notice something important about when they turn out false. And I say, for any if-then statement you like, I don't care what it's about, when the first part of the if-then is true, the antecedent is true, and the second part, the consequent, is false, the whole conditional is false. Here are several examples. Let's just look at the first two. If Boston is in Massachusetts, Cleveland is in Texas, false. Boston is in Massachusetts, but Cleveland isn't in Texas. If Obama is president, Bush is vice president, false again for the same reason. Obama is president, Bush is not vice president. So now we know something for sure. Whenever the antecedent of a conditional is true and the consequent is false, the whole conditional is false. That's just how if-then statements work. Now, we're going to go back to our not P or Q. We're going to say, suppose it's false. We first considered what happened when it was true. Now we're going to consider what happens when it's false. Well, for an or statement to be false is for both parts to be false. Why? Because what we mean by or is at least one part is true. That's inclusive or. If that's wrong, then both parts are false. In this case, if both parts are false, then not P is false. In other words, P is true. And Q, likewise, is false. So by what we just said, when not P or Q is false, if P then Q is also false, because we're in a case where P is true and Q is false. Here's what we got then. When not P or Q is true, so is if P then Q. When not P or Q is false, so is if P then Q. So it seems that they're true and false in the same cases. All right, now we come to the table. Here's the table for when not P or Q is true and false. How did we get this? Well, you know how the table for or works, or you should. So we just notice that here we've got not P as our first disjunct. So, for example, looking at the first row, P, we're assuming in this case, is true, so not P is false. Q is true. That means we have at least one true part, so we have a true or statement. In other words, when P and Q are both true, not P or Q is also true. When P is true and Q is false, not P is false, Q is false, and so neither part of our or is true. Our or statement is false. Here we have a case where P is true, therefore P is false rather, so not P is true, which already means our or statement has a true part. Likewise here, our or statement has a true part. So no matter which of these cases we're in, we can figure out whether not P or Q is true, and we see that this is the pattern. This is the table for not P or Q. This is when not P or Q is true and false. But what we said is that if P, then Q is true and false in the same cases. So there's its table. Now, this might seem a little bit fishy, and some people would say that it indeed is. We could argue about that. We could talk about it. But the point is that first, it helps you understand why someone would think if P then Q has a table and that this is the table. More important, this being the table, it's what you need to know and what you need to remember.